In this video, we are discussing capillary attraction, what it is, and the scientific principles behind it. So there's cohesion, which is different from adhesion. We're going to discuss the difference between them. And finally, the concept of what a meniscus is. Question, what is capillary attraction? A, water flows downwards. B, water drawn is up in gaps. C, air movement in pipes. Or D, heat transfer in water. The correct answer is B, water drawn up in gaps. So capillary attraction, there's two main facets to it. One is the idea of water going up, right? It's going against the force of gravity, which is quite unusual. And in order for it to do that, it relies on gaps between two objects. It can be any two objects, but the gaps are necessary for this capillary attraction to happen because the water uses those gaps to climb up. We'll talk more about that in a minute. So main thing, water's moving up against the force of gravity, and you need small gaps for it to happen. Okay, question, what happens if the gap is wider in capillary attraction? A, capillary attraction increases. B, there's no effect at all. C, less capillary attraction. Or D, water freezes. The correct answer is less capillary action. So one of the basic principles is the more narrow the gap is between the objects, the stronger the capillary effect. So the wider the gaps, the weaker the effect, until the gap becomes so wide that there's no capillary effect at all. Okay, so just to illustrate this, we've got a pan of water and 3 straws. You'll notice the straw on the right, the water level is lowest because the gaps between the sides of the straw are wider. You've got less capillary attraction, less water is being pushed up, and you'll notice that the narrower the diameter of the straws, the more the capillary attraction, so the water goes up more. Okay, question, capillary action under tiles, so roof tiles, can cause A, faster drying, B, less leaks, C, water leaks inside, or D, hotter surfaces. The correct answer is C, water leaks inside. So imagine you've got the roof, you've got your tiles on the roof. Between every tile, there's a very tiny gap, right? Rain falls, goes down the tiles, but instead of all falling to the ground or into the gutter, some of that water finds its way into the gaps between roof tiles and makes its way back up because of capillary action. So in time, what that will lead to is a leak on the inside of your roof. Okay, question. Capillary action can help plumbers to A, paint pipes, B, make soldered joints, C, freeze pipes, or D, cupped tiles. The correct answer is B, make soldered joints. So previously we said is to do with water capillary action, but it can be with any liquid, provided there's a gap there. So if you think about soldering copper pipes together, so you've got 2 bits of pipe and you want to solder them together with a coupling. So you'll know that the coupling, the diameter of the coupling is slightly bigger than the pipe. It has to be, otherwise you can't push the pipe in. But what happens is before you solder it, there's a very, very tiny gap, right, between the pipe and the coupling. Which is a good thing, that's what you want, right? There needs to be a gap, otherwise you can't get the pipe in. And then, what we do with the solder closes up that gap. But because the gap is so tiny, what you can do when you're soldering, you don't need to solder all around the whole diameter of the pipe. You can just solder the bottom of the pipe. And once that solder turns to liquid, by capillary action, it will make its way up the entire diameter of the pipe and give you a good seal. So capillary action is actually very helpful for soldering. So it helps the solder flow into all of the joints. We use it mainly with copper. And again, you can just solder the bottom bit, the bottom quarter or bottom half, and capillary action will cause the liquid solder to make its way around the top half of the pipe, giving you a good seal. Okay, question. Capillary action needs A, sunlight, B, heat and cold, C, adhesion and cohesion, or D, chemicals. Correct answer is C, adhesion and cohesion. So, capillary action requires two things, both of them, cohesion and adhesion. Very briefly, cohesion is water sticking to itself, right? What does that mean? Everything's made of molecules, right, including water. So water molecules have a tendency to stick to each other. If they didn't, you wouldn't get water drops. So cohesion is the water molecules sticking to themselves, forming like a blob or a droplet of water. Adhesion, you still have the idea of stickiness, but water's not sticking to itself, it's sticking to the surfaces around it. So if you think about the word adhesive, we commonly use that for glue. Wood adhesive, for example, is just wood glue. So adhesion is sticking to something else. Cohesion is sticking to themselves. And in capillary action, you got both of them going on at the same time. So, question, cohesion makes water molecules A, repel each other, B, stick together, C, change color, or D, freeze faster. If you're just paying attention, you'll know that cohesion is water molecules sticking to themselves. Right? So, water molecules attract each other. This creates something called surface tension. Then that surface tension is what allows water molecules to form droplets. Question, adhesion makes water A, boil quickly, B, stick to other materials, C, freeze slowly, or D, float in air. The correct answer is B, stick to other materials. So remember, adhesive is one thing sticking to another. To adhere to is to stick to. Alright, so adhesion is water sticking to something else. So, water sticks to other molecules, and this is what allows water to climb the surfaces. So if you think about the picture you just saw a minute ago with the straws in water, it's the adhesion of water. It's water adhering or being adhesive to the insides of the straws as causing it to go upwards. Right, question, the meniscus is A, a pipe fitting, B, a water stain, C, a curved water surface, or D, a cleaning tool. Correct answer is C, it's a curved water surface. See, this isn't something you notice with your naked eye, but it's there. When you pour a liquid into a vessel, like a cup or a test tube, anything like that, what happens is the surface of the water is actually slightly curved. Okay, and the reason why it's curved is because of adhesion and cohesion. Now, the meniscus can either be concave or convex. So if you think about the word cave, how does a cave look? Concave is like that. So in the middle, you'll get the downward slope, and the sides will be sticking up. They'll be higher than the middle. Convex is the opposite of that. Okay, so this is an illustration. So A is concave. Look, it looks like a cave. The outside bits, the water is adhering to the side of the test tube in this case, which gives you this curved shape. B is also curved, but it's curved in the other way. So in this case, the adhesion of the water molecules is stronger. The cohesion of the water molecules in B is stronger than the adhesion. That's why you get a convex shape. In A, the adhesion of the water molecules to the sides of the test tube are stronger than the cohesion of the water. So you get a concave meniscus. So A is a concave meniscus. B is a convex meniscus. And remember, a meniscus is just the curved surface of water in a container. Okay, recap. Capillary attraction. What is it? Is water going up through gaps. The smaller the gap, the more the capillary attraction. Cohesion is water molecules sticking together, sticking to themselves. Adhesion is water molecules sticking to the surfaces that they come into contact with. And a meniscus is a curved surface of water inside a vessel.